Alright, moving on to problem 15. We have 7v cubed minus 10v squared plus 9v to the fourth, looks like. Alright, so 7 is a prime number, and none of these have 7 as a factor, so there's no number factor in common, but they do have two v's in common. So this one, we just have a 1v remaining, no v's remaining, and two v's remaining. So that one was pretty easy. Moving on to 16. We're factoring trinomials now, or factoring different types of polynomials now. Okay, so the first step in factoring completely, and the instructions here are to factor, so that means factor completely, would be to find a monomial factor. Being that there's no number in front of here, we don't have a monomial factor. So the second step would be look for a special case. This is not a PST because this is not a square. So now we're just looking for a pair of binomial factors. In this case, not the box method because there's no A. So we need factors of C that add to B. The first thing that comes to mind is 12 times something. So 12 times 5 would be 60. So I guess that's not going to work. So I'm going to make a little tree here. So factors of 72 would be what? 6 and 6 and 2. So 2, 3, 2, 3, and 2. Alright, so I need to get 17. I could try 12 and 6. That's no good. How about 6? No. How about 9 and 8? Ooh, 9 and 8 works. So 3 and 3 and 2 and 2 and 2. So 9 and 8. And to get the answer here, it's really simple. Now that we've figured these out, you just make your binomials. You know the first terms have to be x's, and then the next ones are the 9 and the 8 that we just figured out. And you should always FOIL to make sure you're right. X squared, 72, and combination of 9 and 8 is 17x. Moving on to number 17. We have 4v squared minus 16v plus 7. Okay. First looking for a monomial factor. 7 again is prime, so none of these have 7 as a factor, so we don't do that. Now looking for special case. This is not a square, so it's not a special case. So we're looking for a pair of binomial factors. This will be the box method because we do have an A. So we're looking for factors of AC, which is 28, that add to B, which is negative 16. So I know the bigger factor is going to be negative because when you add them, they're going to be negative. So let's see, it looks like 14 and 2 will not work. Wait, will they work? Negative 14, negative 2. Yeah, okay. Negative 14 times negative 2 is positive 28, and they add to 16. That works. So now we use the box method. The top left is the first term. Bottom right is that, and then we're splitting that 16v into negative 14v and negative 2v. Now we're factoring. So we have a 2v here, and nothing in common here, so we're going to write 1, but it's negative, so negative 1. Here we have a 2v as well, and here we have a negative 7. So it looks like our answer should be 2v minus 7 and 2v minus 1. Now we'll double check. So we got 4v squared, we have a positive 7, then we have negative 14 and negative 2. So that's negative 16, so that's correct. Moving on to 18. We have n squared minus 16n plus 64. Again, no monomial factor because there's no number here. Special case, perhaps this is a square and that's a square, so we have n squared and we have 8 squared. So if this happens to be 2 times n times 8, which it is, then we can factor it like this. And we're done. That was nice. Okay, number 19. We have a binomial here, so that makes me think we're going to end up with a difference of squares. But first, we have to factor monomials out. 54 is 9 times 6, so they each have 6 as a factor, so we can start here. And this, in fact, is a difference of squares now, so that is going to end up as t minus 3 times t plus 3. And if you FOIL the t minus 3, t plus 3, you will get t squared minus 9. And then if you multiply by the 6, you do get 6t squared minus 54. All right, let's try 20. 20 is y squared minus 121. This is just a run-of-the-mill difference of squares. Nothing too exciting here. Y minus 11, y plus 11, because this is the square of 11. Moving on to 20. Looks like 21, 22 are ones that we're skipping because they have 4 terms, which we didn't do those. So moving on to 23, we have 6n to the 4th plus 15n cubed minus 9n squared. So each of these has a 3 and 2n. So I'm going to factor out a monomial here. 2n cubed, oops, 2n. So 2n squared plus 5n minus 3. And so now looking in the parentheses here, this looks like we could factor it some more. So let's see. There's no more monomial factor. It's not a perfect square trinomial because this is not a square, and neither is this too. So we're looking at box method. So we have AC equals negative 6 and B equals 5. Factors of negative 6 would be positive 6 and negative 1, which also add to 5, so that works. So making our box, we use 2n squared, we use negative 3, and then we have this middle term we're splitting, so 6n and negative n would be that 5n there, and we get that from here. Factoring out, we have 2n, we have negative 1, because there's nothing in common with these two. We have, looks like n here, and then 2. No, sorry, plus 3. Alright, let's see if that works out. So we think it will be n plus 3 times 2n minus 1 with that 3n squared out front. If we FOIL just these two, we would get 2n squared, that's correct. We would get negative 3, that's correct. And then we would get 6n and then minus n, which would be 5n. So this is all good. Moving on to 24. We have another 4-termer here, so we're going to skip that actually, not doing 24. Let's see what 25 is. The area of a square painting. Okay, so we have a square. They're telling us it's a square, so I'm going to draw the square. And the area is 81p squared plus 90p plus 25. We need to know the side length. Well, if it's a square, the side had to have been squared, so this has to be a perfect square trinomial. So that is a square, and so is this. So I think we're in luck, so let's try it out. So this is 9p squared, and this is 5 squared. And so we're hoping that this middle is 2 times 9p times 5. And it looks like it is. So the factor of this would be the base plus the base squared. So 9p plus 5 squared. And let me reread that. What is the side length? Okay, well, this means side squared, so side squared is how you figure out the area of a square, so it's 9p plus 5 is the side length. 26. Write a trinomial with degree 5. All that means is you have to have a 5 up here. So, and it has to be a trinomial, so there's a trinomial with degree 5. 27. Explain how to use the distributive property to multiply two binomials. Include an example. Okay. Okay, what was that? That was 26. Now we're on 27. So I'm explaining how to use the distributive property to multiply two binomials. Well, the distributive property, first of all, I'm going to have to make two binomials. Those look like easy ones. So the distributive property tells us that we have to multiply the firsts, or that each term in the first parentheses has to multiply to each term in the second. So x squared plus 2x plus, oops, not that way, this way. So plus 3x plus 6, and then we combine the middle terms, x squared plus 5x plus 6. All right, 28. What is an expression for the area of the figure? Write your answer as a polynomial in standard form. All right, looks like I'm going to need more room, so let's go here. And we got a little picture, something like so. X plus 1 looks to be this value. 2x is this value. We have 3x is this value, and 2x plus 1 is this value. All right. Well, so looks like we're going to want to, a couple ways to do this. One way would be to surround this into a full rectangle. So find the area of the full rectangle, which would be 3x times 2x plus 1. And then subtract out this square or this rectangle that's not there, right? So the 2x times x plus 1. Okay. So here we'll distribute this. So 3 times 2 is 6, then x times x. 3 times 1 is 3, and then x. Distributing this 2x with the negative, so negative 2x times x is negative 2x squared. And distributing again, negative 2x times 1. Now simplifying, so 6 minus 2 is 4. And then 3 minus 2 is 1. So 4x squared minus x. Right, so, oh wait, plus x, sorry, 3 minus 2 plus x. My bad. Okay, moving on to 29. What are 3 different values that complete the expression so that you can factor it into the product of two binomials? All right, that's easy. X squared plus blank x plus 24. Well, remember, if you're factoring it into two binomials, you need factors of c that add to what? Well, factors of c that add, you could use 1 and 24, so in that case, b would be 25. You could use 2 and 12. In that case, b would be 14. You could use 3 and 8. In that case, b would be 11. So we could find way more than 3. You could do 4 and 6. You could do, I don't know, you could do all these negative, oh no, it says plus. So b could be any of these values. We gave you 4. 30. Write the missing value in each perfect square trinomial. Another easy one. Looks like I'm out of time for this video. Alright, so I will do the last few problems on another video.